Okay, so in this video, I want to show how we can say plot y equals x squared and some other things too. So it's the first change is going to be pretty simple. I'm going to come up here. Instead of saying y is equal to 2x, I'm going to say y is equal to x squared. And I'm just going to do like that. Remember that in we've done x squared before. If x was a number, if we wanted to do x squared, this is the exact same syntax. Well, if x is a numpy vector, it's the same exact thing. We do x star star 2. And what numpy knows to do is it takes every vector in x, it squares that, and puts it in the vector y. So when we do this, we're going to get something that kind of looks like y equals x squared. The only other change I want to make is instead of going from 0 to 4, I want to go from, let's say, -4 to 4, so we can actually see it look like this. And when we first plot this, it's not going to look quite right. So we get something that does not look very curvy. Again, what's happening is y is equal to linspace going from -4 to 4 with five numbers. So if I come down here and look at x, you get -4, 2, 0, 2, 4, and y is going to be the square of all of those. So 16, 4, 0, 4, 16. And what it does at each one of these ordered pairs, -4, 16, -2, 4, and so on and so forth, it plots each one of those points and then draws a line between them. Okay, and so we see a sort of parabola-y shape, but again, it's a piecewise linear function. It's very clearly a piecewise linear function. So if we want to make this a little bit different, if we want to make this look more and more like an actual parabola, we need to sort of increase the resolution, meaning we need to have more points between -4 and 4. And there's a couple of ways to do this. I'm actually going to introduce a new variable called n. N is going to be the number of sampling points, and I'm going to start off by saying n is equal to 10. And this isn't going to be a whole lot different. It'll be a little better, but not quite, not a lot better. Or actually, this is kind of a lot better, but it's still very clearly made up of a bunch of different lines. But if we do something like n is equal to 100, it's going to look exactly like a parabola, and I don't think we'll be able to see any flatness or any linear parts of it. Okay, and so this is what we get. I'm actually don't want to keep reporting that. Okay, and so this is a very good-looking parabola. 100 probably wasn't necessary. Probably even 20 would have done well, but you can still kind of see some lines there, maybe 50. Anyways. Okay, so we can do something similar with y cubed as well. We can plot y is equal to x cubed, something like this, or just another polynomial, x squared minus 2x plus 1, and we get something like this. We can go on, so on and so forth. So polynomials, graphing polynomials are pretty easy, pretty straightforward. The next thing that I want to show you is how to graph sine, let's say sine functions. So your instinct might just be to do sine of x, but we need to do np dot sine of x. And again, what's happening here, NumPy knows how to handle this. Every entry in x is going to take sine of that and store it in the y vector. And so when we plot this, we get a good sine function. Okay, let's say you want y equals e to the power of x. Well, you just change sine to exp, and you get y equals e to the power of x. Or let's say you want cosine, you get this. Or let's say you want tangent, you get this. And so on and so forth. So of course tangent has asymptotes. So when you have asymptotes, you got some kind of strange things going on here, because obviously you're not actually going to plot infinity or negative infinity on this grid here. Okay, so in these 4 videos, we've looked at the very basics of using pyplot and numpy and functions therein to do some very basic graphs. In upcoming videos and next week, we'll look at some other stuff as well.